Let's take a look at another one here. We have another transformation. This one is a transformation T that maps R4 into R3. We want to know if this transformation has an inverse. Okay. So again, transformation X is a matrix transformation, so it's going to be matrix A times whatever our input value X is. Okay. So we're going to look at for what values of Y in the codomain does this work for? Do we ever have no solution? Are there any values of Y that will not work here where this equation has no solution? In that case, the transformation would not be onto. Are there any situations where this has infinitely many solutions? If we have infinitely many solutions, then it's not one-to-one. One-to-one means that for every output, there's only exactly one input that gets us there. If we have infinitely many solutions, then there are lots of x's that can get us here. Okay? So we are going to check by taking the reduced row echelon form of matrix A. So I'm going to get my handy dandy calculator here, throw matrix A into the calculator fast as I can. Okay, and I have the reduced row echelon form of my matrix. So I get 1, 0, 0, 15/8, 0, 1, 0, negative 19/12, 0, 0, 1, 5, 24ths. Okay, so I want to check, let's check first if the transformation is 1-to-1. Okay, so that means whatever Y I would augment this matrix with, whatever I get on this side, if I were to make an augmented matrix, okay, there would only be generally one X that could get us these values, one solution. But if I look at this, notice in the coefficient matrix, this column doesn't have a leading entry in it, doesn't have a leading one, which means I'm going to have a free variable, and that means I have infinitely many solutions to this system of equations. So is it 1-to-1? No. 1-to-1 means it will only have one solution when there is a solution. Okay? There's only one X for every Y in the image of T. Okay, so not 1-to-1. So right there, we know that this isn't going to be an invertible transformation. But just to get to practice, let's see if this is an onto function. Okay, so for an onto function, that means we should be able to plug any y from the codomain in here, and the linear equation will have a solution. So looking at this, will I always have a solution? Well, yeah. There's no row here that would give me no solution, right? And I could let A, B, and C be anything, but I will never get a row that looks like 0, 0, 0, 0, and then some non-zero number. That would be no solution. And I don't get that. Okay, every possible y I could plug in here, this will give me a solution. So yes, it will be onto. Okay, but because it's not 1-to-1, even though it's onto, T does not have an inverse. It is not invertible.